Hello there everyone, this is Zenith and today we will be solving Mathematics Pure 1 May-June 2018 paper 1, variant 2, the course code is 9709. So let's get started. Question number 1. The coefficient of x square in the expansion of 2 plus x over 2 whole power 6 plus a plus x whole power 5 is 330. Find the value of the constant a. So right away we get to know the first question is about binomial expansion. So we can first of all start by expanding both of these brackets. So the first will be 6 0. This is, by the way, in the binomial form. We usually write the coefficients of each of the values of the expansion in this binomial form, which we can also later calculate on our calculator. Right, and then we look at the first term of the bracket, which is 2, and the second term of the bracket, that is x over 2. So the pattern goes like this. You first of all write the coefficient in this form, which is the number power 6 over which coefficient you're looking for. The first one is always labeled as the 0th coefficient. 6 over 0, that will be replaced by the values on our calculator. You could type it on your calculator by pressing the NCR button and replacing n with 6 and r with 0 to get the coefficient value. And we write the first term, which is 2 raised to the power, which is initial power, that is 6, and the second term, that is x over 2, that will have power 0. Then we go on to the second term, where the first term's power decreases. So from 6 we come to 5, and for x over 2 we get the power increased. So you can see the pattern. For the first term the powers decrease along the way, and for the second term the powers increase along the way. You could also do it vice versa, but in this question we are looking for coefficient of x square, and as x square can be found in the starting of the expansion, when you approach it in this manner, we're going to take the expansion in this way. And as we have not yet reached x to the power of 2, we are still going to continue expanding. Then we go 6 over 2, right, 2 to the power 4, and x over 2 to the power 2, and so on. So just over here it's enough. We could keep on expanding, but it's not really required because we have reached the second power, and we just need to look for coefficients of x square, which we have already reached over here. So we can then simplify it. 6 0, we can place it in our calculator. 6 c 0, we get 1. So when you simplify this, you'll get 64 as your first term. Then when we are going to simplify the second one, we're going to get 96x, and lastly 60x square. That's the first brackets done. Now we're going to do the second bracket. A plus x whole power 5. Same thing, we're going to write 5 0, a raised to the power initially, which is 5, and then the second term, which will always start with 0. Then we write the second term, 5 1, a raised to power 4 and x raised to power 1, and then again 5 2, a raised to the power 3 and x raised to the power 2. And if you do not remember exactly how to expand the brackets, well, you don't need to worry, because you will also be given a formula sheet alongside, which will show you exactly how you can expand any given bracket. You can see that they are also following the same format. So in case if you don't remember the binomial expansion, you don't have to worry, it is there in the formula sheet as well. Alright, so till here it should be enough because we have reached x power 2 over here. Then we simplify and we get a to the power 5 plus 5 a power 4x plus 10 a power 3 and x power 2. And now we can construct an equation according to the question. So the question says coefficient of x square is 330. So 330 x square is equals to all of those coefficients of these two brackets. So how can we find an equation which relates all of these values which I found above and 330 x square? Well, we can see that the results of the first bracket and the second bracket are being added together. And as they're being added together, that means we need to look for those terms that when they add will give power x square, or simply to say that we're going to select all those terms from those two brackets which have power of x square, or which have the term x square with them. So we can see from the first expansion that we have 60x square, and from the second expansion we can see that we have 10 a power 3 x square. So only these two are applicable, because when they will add up we will surely get the term x square with it as well. So we can simplify this directly by first of all cancelling out x square, and then we're left behind with 330 equals to 60 plus 10 a cube. And you can see that you're doing the right equation, because we are left with only one variable to find in the equation, that is a cube. Then when we will solve for a, we will get our answer 3. On question 2 part 1, first of all let's see. The equation of a curve is y equals to x square minus 6x plus k, where k is a constant. Find the set of values for k for which the whole of the curve lies above the x-axis. So we can visualize this with a graph or sketch a graph. So they're asking us that we have a curve and we want to find a value of k such that our curve will be above the x-axis. If it's above the x-axis, that means there are no intersections with this curve, and that means there are no solutions or no real roots to this curve. How can this be represented in terms of an equation? Well, for no real roots, we can write b square minus 4ac is lesser than 0. And when we will solve for this inequality, we can find the set of values for k. So we can substitute in the values of the equation. So b was minus 6 whole squared, then minus 4, a is 1, and c is k lesser than 0. When we simplify, we get 36 minus 4k is lesser than 0. And then when we take 36 over there, we will get minus 36, and we're left over here with minus 4k. Now an important thing to do over here, whenever you are dividing or multiplying any sides of an inequality with a negative number, the inequality sign will always be switched. In this case, minus 4 will divide on the other hand side. So it is important that you also switch the direction of the inequality sign. Minus 4 goes on to the other side, divided by minus 36, and we get our answer 9. And the final answer is k is greater than 9. Part 2. Find the value of k for which the line y plus 2x is equals to 7 is a tangent to the curve. So whenever they give you two of the lines and then they're asking you one of the questions which is based on the discriminant of the equation, that means you need to first of all equate both of the equations together. So over here we have y plus 2x equals to 7. Let us first of all rearrange it in terms of y so that we can easily equate it. So this will be y is equals to 7 minus 2x. And now we can equate this with our original quadratic. 7 minus 2x is equals to x square minus 6x plus k. And when we will rearrange this, we are going to get x square minus 4x plus k minus 7. So we got our equation, and now when we will find the Specific discriminant for this, we could apply its condition to this question. In this question, they're asking us that the line y plus 2x equals to 7 is a tangent to the curve. For the curve being tangent, we have to have repeated roots, and that can be represented in terms of p square minus 4ac is equals to 0. And now we can substitute the values: minus 4 whole square, minus 4, 1, and c, it's important over here, is k minus 7, not just 7, k minus 7, and that will be equal to 0. That simplifies to 16 minus 4k plus 28 is equals to 0. And then when you will solve for k, you will get 11. That's your final answer. Question 3. A company producing salt from seawater changed to a new process. The amount of salt obtained each week increased by 2% of the amount obtained in the preceding week. It is given that in the first week after the change, the company obtained 8,000 kilograms of salt. Part 1. Find the amount of salt obtained in the 12th week after the change. So from the question, we can figure out that this is some sort of a sequence or a progression question. But we need to figure out the nth term, because then they're asking us the amount of salt obtained in the 12th week. But we cannot obtain the amount of salt obtained in the 12th week unless if we find the nth term. First of all, we need to figure out what kind of progression is this. Is this a arithmetic progression or a geometric progression? As it is indicated by the word increased by, that means there is some sort of multiplication going on over here by 2% of the amount obtained in the preceding week. We can visualize it over here in this way. Suppose in the very first week we had some x value of salt. So if we then apply the logic of this statement over here, they said the amounts of salt obtained each week increased by 2% of the salt amount obtained in the preceding week. So in the preceding week or the first week we got x. So we first of all find 2% of x. 2% of x would be basically 0.02x. And that much amount added plus the original amount of x. Why added? Because it's saying over here increased. So they're saying it increased by 2% of the amount obtained in the preceding week. So for the next week, the amount of salt will increase by the original value plus 2% of the value in the previous week, and 2% of the value in the previous week would be 0.02x. Similarly, for the third week, we can again take x as the original value, but you do have to remember that you then need to apply the same concept over here. X plus 0.02x. We could also have simplified this whole over here as 1.02x. And now you take the 2% of it and add that over here, and that would be something like 1.0404x. So you can see we're getting some sort of a progression over here. If we simplify this whole progression and write it in this form, 1.02x, and we also simplify this and write this as 2.0404x, you can start by finding the common ratio. First of all, see what kind of sequence is this. Is this arithmetic sequence? No, because it's multiplying by some factor every time. First term, second term, and third term. If it's not the arithmetic sequence, then it's a geometric sequence. If we divide this 1.02x with the x original value, we get the ratio of r. And then if we divide the next term, the third term, by the second term, 2.0404 divided by 1.02, we again get the common ratio of 1.02. Hence we have confirmed that r is equals to 1.02. And now we can start by writing the equation. So we know that the nth term of a geometric progression is represented by a r n minus 1. What is a? Well, they have also given that in the question. It's given that in the first week after the change, the company obtained 8,000 kilograms of salt. First week is the important word to realize over here. So 8,000 kilogram of salt is our original value x in this case. So we are going to put it over here, 8,000 into common ratio r, which we found over here, 1.02 raised to the power n minus 1. And there you go, that's your nth term equation. We have found the nth term equation, but now we need to find the amount of salt obtained in the 12th week. So that's very simple. For the amount of salt obtained in the 12th week, we can just substitute in the value of n by 12, 1.02 raised to the power 12 minus 1. And with this, you'll get your answer as 9946.9 approximately. Then it would be 9950 kg. And that is your final answer for the amount of salt obtained in the 12th week. Part 2. Find the total amount of salt obtained in the first 12 weeks after the change. So what are they asking us in this equation? Basically, sum of the first 12 terms of this geometric progression. Well, if we do not know the formula, we can refer to the formula sheet and we can look for the sum. So we have two equations over here. We have this equation of sum of n terms, and we also have this equation, but this of course cannot apply because this is sum to infinity, and for this one we have r to be lesser than 1. So we just completely ignore this equation and go for this equation, making sure that r is not equals to 1. So we can put this same equation over here first of all. So we know that sum of n terms of a geometric sequence is represented by a multiplied with 1 minus r raised to the power of n over 1 minus r. So for the sum of the first 12 terms, or for sum of the first 12 weeks, we can find it out by writing 8,000 as a, 1 minus 1.02, that was the common ratio raised to the power 12, because first n terms, 12 terms, and then over 1 minus 1.02, and that gives you the answer approximately 107.1 2 3 zeros followed by it. So your answer is 10700 kg. Question 4. The function f is such that fx is equals to a plus b cos x for x is greater than 0 or equal to 0 and lesser than or equal to 2 pi. It is given that f 1 by 3 pi is equals to 5 and f pi is equals to 11. Part 1. Find the value of the constants a and b. First of all, let's start by writing what we already know. F 1 by 3 pi is equals to 5. So we can write this as a plus b, basically substitute the actual equation over there, a plus b cos 1 by 3 pi is equals to 5. When we simplify this, we get a plus 0.5 b is equals to 5. That's your first equation. Now for the second equation, which is f pi is equals to 11, we can again expand this. So we have a plus b cos pi is equals to 11, and that leaves us with a minus b, when we simplify it, is equals to 11. When we rearrange it, we get a is equals to 11 plus b. Now we're going to substitute this equation in the first equation which we made. So a over here will be 11 plus b plus 0.5 b is equals to 5. And when we will solve for b, we will get b as minus 4. And similarly, if you're going to substitute the value of b over here, 11 minus 4, we will get the value of a as 7. Part 2. Find the set of values of k for which the equation fx is equals to k has no solution. First of all, let us write what is the question asking us exactly in the form of an equation. 7 minus 4 cos x. Why 7 minus 4? Because now we have actually got the values of a and b. We just substitute them back into the equation. 7 minus 4 cos x, which is the fx equation, will be equal to k. Right. And now we should arrange it for cos x. I'll tell you why in a minute. Cos x is equals to k minus 7 over minus 4. When we have rearranged it for cos x, we get certain limits which we cannot cross. The value of cos x only comes between 1 and 0. Over here we can establish a relation, and even you can put this on your calculator and experiment, right? You could check on your calculator that whenever you would put any value, cos whatever value, the answer which you will get will always be lesser than or equal to 1, but greater than or equals to minus 1. You could either remember this or you could try figuring it out on your calculator, but it's best if you remember the boundaries for cos x. You could also check for the boundaries of cos inverse x. We're just going for cos x. We could have also just brought cos to the other side and make x is equals to cos inverse, and then we could have checked the boundaries for that likewise. But for this, we will just go with cos x because it makes stuff much simpler. So now that we have found this relation, we can substitute instead of cos x the actual other part of the equation, because we have just said cos x is equals to k minus 7 over minus 4. So then we can substitute instead of cos x, we can write k minus 7 over minus 4 and put it in between the inequality. And now we're going to solve for both of these inequalities. But if you're going to solve for this inequality, we would get basically the range of values for k for which we have a solution. So what do? From this, we need to split it into two separate inequalities, because this inequality just gives the boundary values for cos x, between which cos x gives a valid answer or has a solution. So if for this inequality, k will have a solution. So from this, we can understand that k minus 7 over minus 4 will not have a solution if its value is lesser than minus 1. So if its value is lesser than minus 1, why not lesser than and equal to? Because then it would include minus 1, and minus 1 is a valid answer. So we just said over here, k minus 7 over minus 4 will be valid if it's greater than minus 1. So if we want it to be invalid and have no solution, it must be lesser than minus 1. That's one of the inequalities. Similarly, for the other one, we can write k minus 7 over minus 4 to be greater than 1. Why not greater than or equal to 1? Because 1 itself is also a solution. So giving it greater than 1 would mean it would have an invalid solution for cos x. And now we can solve each of these separately. For this one, we will get k is greater than 11. For the second one, we'll get k is lesser than 3. And that's your final answer. Question 5 will be omitting, because as part of 2024 syllabus of Pure 1 Math, vectors are not included in the syllabus. So we'll be entirely skipping this question. On to question number 6, a question about radians. The diagram shows point A and B on a circle with center O and radius R. The tangents to the circle at A and B meet at T. The shaded region is bounded by the minor arc AB, and the lines AT and BT. Angle AOB is 2 theta radians. Part 1. In the case where the area of the sector AOB is the same as the area of the shaded region, show that tan theta is equals to 2 theta. Okay. So they have just said that this whole area over here is equals to this area. Sector AOB is equal to same area as that of the shaded region. So this shaded region has the same area as the area AOB. That's one of the conditions which they have told us. Secondly, from the questions, we can identify that we can symmetrically cut this shape from the center. And through properties of circles, we can also realize that radiuses and tangents always meet at 90 degrees. BT and AT are tangents as said by the equation. And through circle properties, we know that radius and tangents meet at 90 degrees always. So we can mark those 90 degrees over here. So first of all, let's see area of AOB, area of sector AOB. So the way we're going to approach this is first of all by completing all the conditions. They said that area of sector AOB is the same as the area of the shaded region. So first of all, let's find the area of sector AOB, then the area of the shaded region, and then equate them in order to get to tan theta is equals to 2 theta. So area AOB is equals to 1 by 2 r square theta. That's the formula. We can substitute in that the values. R square will be r square. We have r. But in case of theta, we have 2 theta. That cancels out. And we're left behind with r square theta. And then we need to find certain lines before we can calculate the other area. So they have now asked us for the area of the shaded region. We have found area AOB, but now we need to find the area of the shaded region. What exactly is the shaded region? The shaded region is all of this area. So let's try to break down this into a simpler shape. We know that this forms a kite and these both angles are equal, OAT and OBT. So as it's a kite, according to the properties of a kite quadrilateral, we can split it down through the center and both of the triangles OAT and OBT will be equal. Right. So how will we find the shaded region? To find the shaded region, we first of all have to find the area of one of these triangles and add it to the second triangle because basically they are made out, or the whole shape is made out of two triangles, and then subtract that whole area from AOB to get the shaded region. So we will first of all be looking for the area of OBT, but we can't find the area of OBT because the length of BT is unknown. So to find the length of BT, we will use trigonometry. So when we said that we split this exactly half, that meant that this angle would also be theta and this angle would also be theta, equally split through the center. So we have the angle, we don't have the opposite, but we have the adjacent. So these three values can be related through tan theta. Tan theta is equals to BT, opposite over adjacent, that is R. In this case, we can represent then BT as tan theta R. Now that we found the base and the height respectively, we can now calculate the area of OBT. First of all, that will be 1 by 2 base into height. So in this case, base was, take R or tan theta, I'll just take it as tan theta R, and the height R. Simplifying this, we get tan theta R square over 2. And now we found area of OBT. So to find area of AOBT, because we need to find the whole area of the kite and then subtract the sector from it to get the shaded region. So we are going to find area of OBT, area AOBT. We'll be just multiplying all of it with 2, tan theta r square over 2. 2 and 2 cancel, and we're left with tan theta r. Tan theta r square, and that's the area of AOBT. Finally, the shaded area will be, if we go back up, we have found AOBT area. So the shaded area will be the area of AOBT subtracted from the area of the sector. That would be tan theta r square minus r square theta. So now if we look back up to the question where they said that area of sector AOB is the same as area of shaded region, so now we can equate both of them. Area of the sector is equal to the area of the shaded region, tan theta r square minus r square theta. And now we have found the final equation. We just have to rearrange it. We bring r square theta over there. R square theta plus r square theta gives us 2r square theta. We can consider this whole thing as a single term, and we're left over here with tan theta r square. R square cancel from both of the sides, and we are left behind with tan theta is equals to 2 theta. Hence proved. Part 2. In the case where r is equals to 8 centimeters and the length of the minor arc AB is 19.2 centimeters, find the area of the shaded region. Okay, so they haven't told us certain items such as the theta angle, so we really can't find the sector area. If you look back up to the original equation, the shaded area had the sector area subtracted from the total area of the kite, but for that we need the angle theta, which we do not have, but we can get it from the arc. So the arc length is equals to the radius into theta. We have the arc length, that is 19.2 centimeters, and we have the radius, that is 8 centimeters. We need to now find theta. So theta would be 2.4 degrees or 2.4 radians. Next, we need to find again the lines, the same process. You saw over here we were finding first of all BT, and then we were multiplying it by 2. We're going to follow the same process. Again, we need to find BT using the same relation of tan theta. Remember, we divided the original angle by 2, so in this case as well we would divide 2.4 by 2 as we're looking for the area of one of the triangles OBT. So BT over 8, that's the radius now, and we would get BT as 20.577. Right, now for the shaded area, that would be AOBT area minus AOB area. So AOBT area would simply just be 2 multiplied with area of OBT. What is area of OBT? The base into height multiplied with 1 by 2. 1 by 2, 8 into 20.57, that would the sides of the half triangle, multiplied with 2, that would give us the whole area of AOBT. And AOB area, that's a sector. So for sector it would be 1 by 2 r square theta. R in this case was 8 square and theta 2.4. When we will simplify this, we would get our answer as 87.8 centimeter square, and that is the area of the shaded region. Question 7. The function f is defined by f of x 7 minus 2x square minus 12x for x is a set of real numbers. Part 1. Express 7 minus 2x squared and minus 12x in the form a minus 2x plus b whole square, where a and b are constants. By far one of the easiest questions. Minus 2x, this whole will be equals to minus 2x square minus 12x plus 7. It's always a best practice to first of all rearrange it so that x square is the first term. Now the first thing we're going to do to bring it in the completing the square form is that we're going to take out the common. The common in this case was minus 2. So when we take out common from all three terms, we're left behind with x square plus 6x minus 3.5. The next step would be x square plus 6x, the same as it is, plus half of the middle term, or half of the middle term now in the brackets, by the way, half of the middle term, which is 6, that would be added one time squared and subtracted one time squared. So half of the middle term squared will be added one time and subtracted one time, which would be 3 squared, one time added, and then 3 square, one time subtracted, minus 3.5 as it is. And then in the next step, we can combine and write x plus 3. X plus 3 square. We took the positive value of 3 and we put it in the bracket with x. That bracket is done. What is left outside now is minus 3 square minus 3.5. So now we can simplify it. Minus 2x plus 3 whole square minus 3 square minus 3.5 multiplied by 2, that gives us plus 25, and now we have got it in the form. Now part 2. State the coordinates of the stationary points of the curve y is equals to fx. Stationary point means the turning point. To find the turning point from completing the squared form, it will always be p and q, where p is basically minus of the inner term and q. It should be minus p plus q. Just a minute. This must be minus p and q, where p will always be the term which is inside the brackets and q will always be the term which is outside the brackets. That means our coordinate was inside one is minus 3. If this would have been minus 3, then it would have of course been plus 3. Minus 3 and q would be 25. Part 3. The function g is defined by gx 7 minus 2x square minus 12x for x is greater than or equal to k. Basically, it's the same quadratic but given for another function with another range. State the smallest value of k for which g has an inverse. Now, an inverse can only be formed for those functions which are 1 to 1. Quadratic functions are not 1 to 1. They can become 1 to 1 if we split them from their line of symmetry, and their line of symmetry is from their turning point. So either of the halves, graphs of either of the halves can be the inverse graphs, but not the whole graph. The whole graph cannot be considered as an inverse. So what I just said, that if you take the turning point, that would be part from where you can make your inverse. So the smallest value of k for which g as an inverse would be the turning point which we calculated in the previous question, and that would be 3 minus 3. Part 4. For this value of k, find g inverse x. Alright, so y is equals to minus 2 x plus 3 whole square plus 25. Basically, instead of gx, I wrote y is equals to, because we're going to rearrange it for y and then we're going to find the inverse. And instead of writing 7 minus 2x square minus 12x, I wrote the completing the square form, because this equation and the initial equation for fx are both actually same. So now when we make x the subject for this, y minus 25 over minus 2, and on this side we'll have x plus 3 whole square. And now when we will take this square to the other side, it will become a root. Y minus 25 over minus 2 is equals to x. and plus and minus always comes with the roots. But for this question, you would have to carefully look whether the minus is applicable or the plus is applicable. How you can do? By substituting in the values. Try substituting in the value of g inverse x. So what is the for this, how can we realize if it's a positive sign or negative sign with the root? Simply, first of all, let's determine what will be the range of this. So what was the domain of the original equation? The domain of the original equation was x is greater than or equal to minus 3. The domain of gx will now become the range of g inverse x. So the range of g inverse x would now basically be the domain, that is, it would be greater than or equal to minus 3. So you could now try substituting minus 3 into this original equation, try it with the minus and then try it with the plus, and see if it gives the value lesser than or equal to. If the value which it gives would be, by the way, this is the range, but we haven't known the domain yet. So for the domain, you will of course have to find it, and when you would find the domain value, you would substitute it over here and see if it gives a value lesser than the value of minus 3. If it gives value lesser than minus 3, then we are not going to take that sign, and for this case it was minus, which gave a value lesser than minus 3. By the way, over here it should be minus 3 as well, we brought from the other side. So therefore we can conclude that g inverse x would be just the root, not minus sign, only the plus sign, x minus 25 over minus 2 minus 3 outside. And now we have question 8. Points A and B have coordinates HH and 4H plus 6, 5H respectively. The equation of the perpendicular bisector of AB is 3x plus 2y is equals to k. Find the values of the constants h and k. So first of all, let us try visualizing what we have over here. The equation of the perpendicular bisector of AB. First of all, let us think of the perpendicular bisector. That's the perpendicular bisector. In the middle of this, we would be having a line. Let us make it in this way. Suppose this is our line AB. Right in the middle, we would have the perpendicular bisector. And this perpendicular bisector would have the equation 3x plus 2y is equals to k. What they have given us that A has the coordinate HH and B has the coordinate 4H plus 6 and 5H. So now that we are given this relation, we can try substituting and finding for these equations. So first of all, what do we have exactly? We have the 2 points, we have the equation of the perpendicular bisector, and we also know that both of these are perpendicular, so we could apply the perpendicular property of lines. M1 into M2 is equals to minus 1. So first of all, let us try finding the gradient of one of these lines. We can't find the gradients of A and B right now because we of course do not have value of H, but we can find the gradients of the perpendicular bisector if we rearrange it. So 3x plus 2y is equals to k, because of course the gradient is always the coefficient of x, so it doesn't matter if there's a k beside it, k won't affect it for now. So we take 3x on the other side, this would become k minus 3x, and that both of them will be divided by 2. And from this we can identify that one of the gradients, which is of perpendicular bisector, is minus 1.5 or minus 3 by 2. We know now that one of the gradients is minus 1.5. So the gradient of AB would be such that when you're going to multiply it, you're going to get minus 1. The property of perpendicular lines would be that the gradient of those two perpendicular lines would be equals to minus 1. One of the gradients we already know, that is minus 1.5. Now we need to find the second gradient, and that second gradient would be of AB. This M2 over here, which we will find, will be the gradient of our line AB. That will be over here 2 by 3. So we have now found the gradient. So now that we have found the gradient, we can find an equivalent equation in which we can put a and b as a gradient. Because gradient is based on two of the points, we can of course use them as y2 minus y1 over x2 minus x1 and equate it now to the gradient and solve for h. So y2 minus y1, let's take points of b as y2, which is 5h minus y1 h over x2, that is 4h plus 6 minus x1, that is again h. And when will you solve for this, you're going to get h as equals to 2. Now that we have found h, we can write for sake of clarity that a is 2 2 and b will be 14 10 after simplifying. So now that we have found this, we can now see bisector of AB is 3x plus 2y is equals to k. Find the values of constants h and k. So now how can we find k? Well, we need to look for a point that is on the line of 3x plus 2y is equals to k. How do we find that? We know that the perpendicular bisector lies on the midpoint of the line that it bisects. So we know a and b. So we don't need to find the equation of its line, but rather its midpoint. So the midpoint would simply just be of a and b. 2 plus 14 for the x coordinate over 2 and 2 plus 10 over 2 for the y values, and we will get 8 6. So this is a point that lies on the point, this is the line, this is a point that lies on the line AB and also on the perpendicular bisector. We can now substitute this into the original perpendicular bisector equation, which was 3x plus 2y is equals to k. That would be 3 8 plus 2 into 6 is equals to k, and then we get k is equals to 36. That's our final answer. Question 9. A curve is such that dy over dx is equals to under root 4x plus 1 and 2 5 is a point on the curve. Part 1. Find the equation of the curve. So this is of course a question of integration. When we're going to integrate the derivative, we are going to get the original equation. So y is equals to 4x plus 1 raised to the power 0.5. We just eliminated the under root and made it simpler to integrate now with respect to dx. Now you should remember the way we're going to integrate this is that because this is having also a terms inside the bracket, we are also having 0.5 that is outside the bracket, but we also need to remember that the values that are inside that will also get integrated. So for this, you could remember it in this way: the integrate or the indefinite integral of ax plus b raised to power n is basically equals to ax plus b raised to power n plus 1, of course, over the power n plus 1. But this is just the integration for the terms outside. You need to also integrate the values that are inside the brackets. And by chain rule, of course, then you're going to multiply it with 1 over a plus the c constant, of course. But note, this can only apply if x doesn't have any power, or if the power of x is 1. In this case, the power of x is 1, so we can also apply this same thing over here. So when we drop the power, we get 2, and down it will be 0.5 plus 1. We will have 3, and over here then we would have 4x plus 1, and the power would be 1.5. And then you're going to multiply this with the integrand inside, which would be 1 over a, and that would be 1 over 4 plus c. Now we can calculate 2 over 3 into 1 over 4, and we can simplify this. So y is equals to 4x plus 1.4x plus 1 raised to power 1.5 over 6 plus c. But this is not our final equation because we still do not know what is this arbitrary constant c. Well, luckily they've given us the original point. So we're just going to substitute the point in this original equation now. Y will be 5 and 4, x would be 2 plus 1 raised to power 1.5 over 6 plus c. And for this we can solve and we will get c is equals to 0.5. And in that way we have found the original equation, that is 4x plus 1 whole power 1.5 over 6 plus 0.5, and that's your final answer. Part 2. A point P moves along the curve in such a way that the y coordinate is increasing at a constant rate of 0.06 units per second. Find the rate of change of the x coordinate when P passes through 2, 5. Let us first of all list what information we already know. We know the rate of change of y. Rate of change of y can be written as dy over dt. dy over dt is 0.06. We need to find rate of change of x, which can be written as dx over dt. We do not know what is this. So now we need to find some way to relate both of these. We can use the chain rule of differentiation over here. And we can write that dx over dt will be equals to dy over dt. And now we need to multiply with this something so that we can get dx over dt. Clearly we can see that dt must remain where it is. We need to cancel out dy in some one way or another. Well, in such situation we have a third value over here, that is dy over dx, that is given to us. But we can't just directly write dy over dx. Instead what we can write is dx over dy. Why? Because dy in the denominator will cancel with the dy in the numerator over here, leaving us behind with dx over dt. Now you might be wondering, what is dx over dy? First of all, let us write 0.06, that is dy over dt, and dx over dy is simply just dy over dx inverse. So it would basically just be 1 over dy over dx. dy over dx was given in the first question as 4x plus 1. That's it. That is dx over dy. But we are going to find the rate of change of x when we had the value of 2. So we're going to write instead of x 2 over here. So 0.06 multiplied with 1 over 4 into 2 plus 1, and we're going to get rate of change of x, that would be 0.02. That's your final answer. Part 3. Show that d2y over dx square multiplied by dy over dx is a constant. Let's write this in a form of equation. So first of all, let us find what is d2y over dx square, as we do not know what is that. d2y over dx square will be of course done over the first derivative. What was the first derivative? The first derivative was 4x plus 1 raised to the power 0.5. Let us write it over here. 4x plus 1, 0.5. We're going to find the second derivative of this. That would be bringing down 0.5, 4x plus 1, power minus 1, that would be minus 0.5, and we also have to differentiate the inner term as well because this has a bracket as well. We're going to multiply that inner derivative, which would be 4x plus 1. Derivative of 4x plus 1 is simply 4. And we find the second derivative as 2 4x plus 1 raised to the power minus 0.5. And now just let's write the equation that d2y over dx square into dy over dx. Let's write that. So that would be 2 into 4x plus 1 into minus 0.5. Let's write this in this way. It was minus 0.5, so first of all 4x plus 1 will go down, and it was 0.5, that means it would be an under root. So basically this is the second derivative written in this form instead of writing it as minus 0.5. That will be multiplied with the first derivative, that is 4x plus 1, and we can clearly over here see that 4x plus 1 cancels out and we're left behind with 2, and that's it. That is the way you're supposed to show that d2y over dx square into dy over dx is constant, because 2 we have found over here is a constant. There are no variables and therefore the value is constant. Question 10 part 1. Solve the equation 2 cos x plus 3 sin x is equals to 0 for x is greater than 0 and lesser than 360 degrees. So the way we should solve these questions is, first of all, you should look if it's possible to simplify it by combining cos or sine. Usually when equations involving cos and sine are given, you should first of all look if there's a way of rearranging them and solving them through the use of tan, because usually you would be able to then find many solutions and much more accurate solutions as well. But if it's not possible to combine or rearrange the equation in such a way that you would then get tan x, then you could substitute it using the identity, which is cos square x plus sine square x is equals to 1. In this case, let us see if we can arrange this equation in such a way that we can get tan x, because that then would give us more accurate solutions. So we can take 2 cos x and we can write the 3 sin x on the other side, minus 3 sin x. And we can clearly see that we can get a tan in this way. What is tan? Tan x is simply sin x over cos x. And in case if you don't know the ratio is also given in your formula sheet. Tan theta is equal to sin theta over cos theta. So what we can do, we can take the cos on the other side and bring minus 3 on this side. 2 over minus 3, whereas in this side we will have sin x over cos x. The whole point of finding and replacing this term with tan is to get more accurate solutions and multiple solutions. It is an easier way to find solutions. So we can then replace it with tan x, and on this side we have 2 over 3, minus 2 over 3. And now if we solve for x, you can even substitute it in your calculator. The very first value you would get is minus 33.6, which is obviously not the value we're looking for because it is outside of the range. We need to add into this value so that we can bring it into the range. So we know that the graph of tan or tan theta repeats every 180 degrees. So all we need to do is to find the other angle by adding 180 degrees in it. So we add 180 degrees to our first angle and we get one of our first solution, that is 146.3 degrees. And we can again add into it 180 degrees. We can add 180 degrees into 146.3, or we can just add into minus 33.6 360 degrees, which is basically 180 degrees but added two times. That gives us 326.3 degrees, and these are your two solutions. Part 2. Sketch on the same diagram the graphs of y is equals to 2 cos x and y is equals to minus 3 sin x for x is greater than 0 and lesser than 360. So of course we will be sketching the graph where on the x-axis and y-axis you don't necessarily have to show the values, but for the sake of drawing an accurate graph you could draw the values. So on the y-axis we know we have values 0 to 1, minus 1 and 1, but in this case the graphs are being stretched. This is an example of transformation. We are stretching the graphs parallel to the y-axis, so the values will go all the way to 3, both above and below 0. And On the x-axis, you would have the angles 90 degrees, 180 and 270. We don't need to worry much about that because there is no stretch parallel to the x-axis. So first of all, let us see how would the graph basically be for y is equals to minus 3 sine x. For y equals to minus 3 sine x, we have basically stretched it so that now its values would reach up till 3 and minus 3 on the y-axis. And if you really do not know how to properly stretch it according to the transformation, you can always make a table of values in your calculator and then use it for some of the standard angles. So find one of the points for 90, then 180, then 270, and then up till 360. In this way, you could then connect the dots and have a nice sketch of the graph. The graph basically would look something like this. For y is equals to minus 3 sine x, where you would have the top and the bottom parts coming up till minus 3. Rest will remain same, and the angle of course would also remain same. Similarly, for y is equals to 2 cos x, it would start at 2, go all the way up till minus 2. That would be your graph of y is equals to 2 cos x, and that would be your graph of y is equals to minus 3 sine x. This was just a basic simple sketching. Part 3. Use your answers to part 1 and 2 to find the set of values of x for which 2 cos x plus 3 sine x is greater than 0. What we found over here in the first question was just the values at which we would get 0. So if you would substitute 146.3 and 326.3 degrees, you would get the value of 0 for the equation. So they have said use answers to part 1 and 2. You can't really use part 2 as much as you could use part 1. For part 1 we had found two values, but how do we determine the two ranges? Well, you could do this by one of the methods that I call it boundary compare method. Basically, check on either sides of 146.3 degrees and 326.3 degrees if the values are increasing or decreasing. Simply substitute value of 146.3 into the equation. You would of course get an approximate value of 0. Now, instead of using 146.3, substitute in it some value that is smaller than 146, like 130. When you would substitute that, the answer you would get would be positive. Now, if you would substitute a value like 120 in it, not 120, if you would substitute a value higher than 146, like 150, you would get the answer negative. So in this case, we can see that if we go greater than 146, we would get a negative value, and if we would go lesser than 146, we would get a positive value. And by doing this boundary compare method, for 146, we can get one of the ranges, that is x would be lesser than 146.3 degrees. While lesser than and not lesser than not equal to, because if x would be equal to 146.3 degrees, the answer would simply be 0 as previously said. Now let's do the same thing for 326. For 326, take some smaller value like 310 and then take some larger value and substitute it like 330. Just a small larger value like difference of 10 value 10 points above and 10 points down. And for this, you would find then the range to be x is greater than 326.3, because when you would substitute, for example, 330 degrees, you would get positive value. But if you would start substituting values like 310, smaller values than 326, you would start getting negative values. So this is one of the ways of how you can find the range if you really don't have any other way of finding, kind of like a last resort if you can't manage to find the ranges. So these are your two final answers. X is lesser than 146.3 degrees and x is greater than 326.3 degrees. Question 11. Diagram shows part of the curve y is equals to x over 2 plus 6 over x. The line y is equals to 4 intersects the curve at the points P and Q. Show that the tangents to the curve at P equals to P and Q meet at a point on the line y is equals to x. So basically what they're saying is that for point P and for point Q, we will have to first of all have some tangent to it. And they're saying that the tangents of these 2 points intersect at such a point that this point lies on the equation y is equals to x. So once we have figured out what we have to do, we understand that we have to first of all find tangent for P and Q. How can we find the tangent? Well, first of all, we have to derive the equation, because you can only find the derivative, then only you could find the gradient. To find the tangent, we need to know the gradient at the point P and gradient at the point Q. And for that, we need to derive the original equation. So we need to find dy of dx, dy over dx of 2 inverse x, bring everything to numerator, and 6 inverse x. We could add the 0.5x as well. And when you would derive this, you would get 0.5 and minus 6x raised to the power minus 2. Right, that's the derivative which we have found. Now we need to look at the gradients at point P and at point Q. So how do we find these 2 points? Well, first of all, we need to get to know the points. We have found the gradient function, but we yet need to find the points of P and Q. So for P, we do not know what is x, but we know what is y, that is 4. Similarly for Q, we don't know what is x, but we know what is the y value, that is 4, because it's staying on a constant line, that is 4. So what we can do is simply equate this equation equals to 4, because we need to find the points of intersection first of all, x over 2 and 6 over x. And when we would solve, we would basically get a quadratic equation, which makes sense because there are 2 points of intersection. So quadratic equation which you would get is x square minus 8x plus 12 is equals to 0. And now when you would solve this, you would get 2 points. X1 is equals to 6 and x2 is equals to 2. And for both of them, y is equals to 4. And with this, we can also conclude that P is 2, 4 and Q would be 6, 4. Why 4? Because they're all lying on the line y is equals to 4. Now that we have found P and Q, we can try finding the equation. All right. So we need to find the equations of their tangents first of all. Let's find the equation of the tangent of line P first of all. How? Y minus y1 is equals to mx minus x1. That is the equation of a line. Y minus y1, that is in this case 4, is equals to m. M we are going to find at that point, which we can put it in this value, 0.5 minus 6, and substitute value of x over here, 2 minus 2, that's the gradient from the derivative we have found, into x minus x1, and x1 was again 2. And when we simplify this, we get minus 1 for the gradient value, x minus 2 and y minus 4. When we simplify, we get the equation of the line as minus x plus 6. That's for the point P. But now we also need to find for the point Q. Similarly, y minus 4 for point Q is equals to the gradient. Again, substitute the point 6 into the gradient function, 0.5 minus 6 x whole power inverse 2, and you would get the gradient as 1 by 3 after substituting the point of Q, x coordinate of Q, 6. 1 by 3 and x minus x1, that is 6. And we are going to simplify it, and we're going to get 1 by 3x plus 2. Now these two are the tangents to the point P and Q. And as we previously stated, we need to prove that both of these intersect at such a point that they lie on y is equals to x. When we're talking about intersection, that means we solve simultaneously. We're going to equate both of these together. 1 by 3x plus 2 is equals to minus x plus 6. And when we solve this, we're going to get a value of x that would be 3. And when you would substitute this x value into any one of these equations, you would get the value of y of 3 as well, hence saying that x is equals to y, and it lies on the line as x equals to y. And that's it. The points of intersection we get are 3, 3. Therefore, the point of intersection was 3, 3. And that scores you the mark. Part 2. Find, showing all necessary working, the volume obtained when the shaded region is rotated through 360 degrees about the x-axis. Give your answers in term of pi. Well, for this, we would have to do definite integration. Let's erase all of this and let's see how we can approach this question. Right, so we need to find the area that is enclosed between these two parts. So how do we do it? Well, that would be the area occupied between the x-axis and line y is equals to 4 minus the area occupied by the curve and the x-axis. Why we're subtracting from y is equals to 4's area? Because that is having the more greater area. So now that we have established this relation, we can also write the equations, of course, as well, just to make ourselves more neat. We can write first equation, that was 0.5x plus 6x inverse, that was the equation of the curve, as fx. And the second equation, we can write it as gx is equals to 4. We gave them these labels for the sake of simplicity. And to find the volume, that would be the definite integral between the limits of q and p, because I said when the shaded region is rotated and the shaded region is enclosed by the curve, the line, and the limits. Limits will be taken, of course, of the x coordinates, limits q and p, and that would be found by pi y square dx. And this y square, I'm going to tell you in a minute what does it exactly represent in the case of two equations. In the case of two equations, first of all, the very first thing you should do is that you should remove any constants that are in the integrand. Pi is a constant, we can just bring it outside the integrand. Q and P were 6 and 2 respectively, and y square is actually gx minus fx whole square. G of x minus f of x whole squared dx. This is basically y. And if you think this is too complex and you cannot solve gx minus fx together, you can further split this. Pi, we can also write this whole statement above gx minus fx in this way, where we have pi integrand 6 2, and we would have gx whole squared, remember the square, dx minus pi integrand 6 to f of x whole squared dx. So we have now split these further into two separate integrands, making our life much more easier. So now we can put in the original equations. That would have pi 6 2, this would be 4 whole square, minus pi 6 2, fx was 0.5x plus 6x inverse, and now we can simplify this. That leaves us behind with pi 16x minus pi with the integrand 6 2, not the integrand, you can just write it directly as well. So we can simply write it as now minus pi, substitute the brackets, and then we also have to find the square of this. So in short, the square would be basically 0.25 x square plus 6 plus 36x raised to the power minus 2, and again with the limits 6 2. And now you can directly put this actually in your calculator. You can put on the integration calculator, and then you can substitute the limit 6 2, and when you subtract both of these values, by the way, the values we get for these are 64 pi and 160 over 3 pi. And when you simplify for both of these and subtract them, you get your answer, final answer, as 32 over 3 pi, or you could write it as mixed form as well. So that was this paper done. I hope you had enjoyed and understood. Please subscribe and like, and do leave a comment if you think you had understood this paper. Thank you, and I will see you in the next video. Goodbye.